Hey everybody, this is Rydo, and we are back to 7 billion humans. So we finally hit on level 38 the puzzle I couldn't solve in the time allotted. And there's a lot of ones where we just haven't gotten every single challenge done. I think there's a possibility, and no promises, that I might do a lot of these off screen. Um, did I solve this? Well, it's lit up, so I guess I did. Probably did. It'd be blinking otherwise, I suppose. But that does put us in a dangerous position, certainly, because if I can't figure out any of these right path ones, I'm going to have to either look up the solution or give up, which I don't want to give up for sure. So let's do 37 dangerous spreadsheeting. Hiccup. Ugh. Did everyone have fun at the holiday party? Oh, you weren't invited. Well, I'm sure cleaning up after a party is just as fun as being at the party. It appears someone got into this room and damaged a hiccup bunch of data. So the tech support people want us to take inventory. See the table down there? I guess this is a table. Just add up each row and write the total sum of each row in that column over on the right. That should be R-I-G-H-T. I mean on the right. Ugh, it was a rough night. Watch out for the hiccup holes. Well, this is interesting. And see, the problem that we've run into is that since each person kind of has their own internal memory, there's no shared memory. It's all sandboxed. It's kind of like, well, if you were doing class programs, it's kind of like a private variable where that variable is only inside the class and cannot be accessed, or a non-global local variable in a function where same thing. And that doesn't really help in any way to have multiple iterations of the same program running at the same time. So how do we get around the holes becomes the question. And they've done this specifically so that that this is going to be a pain. Okay. So, step to the right if this is to the right is not a hole. And then, or, while we're at it, we'll just say also if it's not a wall. Because once we get to the wall, we'll get to that. And then we are going to set to memory 1 the value that is there, and then we are going to calculate in memory 2 the what is memory 1 plus let's see, we need to probably establish a memory 2. So plus memory 4. So let's see, set memory 4 to 0 and add memory 1 to memory 4. There we go. If it's not that. Go and drag that up there. and drag that there. This is probably the wrong way to do this. What we need to do is just have the if command be if you see a hole, then step down, and this will work in this case but not every case. Step down to the right, and then if a direction up here is clear, is not a hole, step this way. I'm customizing this code pretty badly. Elsewise, step this way, then jump, through that loop. And that fixes getting around the holes. The next if statement we would need would be if directly to the right is a wall, pick up what is under you, write down memory 4, drop it, and then end. And see, that kind of happens at the end, so that should probably be down at the bottom. The order of a lot of this stuff should make more logical sense in code, and it should be kind of chronological, or the expected chronology if there is an expected chronology. Let's see if that works. Nope, not quite. If directly to the right of you is a hole, see if that works. Do the math. I need a jump function out this way, or I can move this jump function over that way, and that probably will fix that. A little bit of just adjustment. There definitely is a problem with the way this game tries to make it seem like a lot of things are automated, but then doesn't give you a good system to be certain about what it's going to do and what it isn't going to do. So there is this just overall possibility that it might act in unexpected ways, and that's not what you want for computers. So that looked like it did what it was supposed to do. Let's follow this person as we follow this person as we step through it. Okay. She should now get 5 in memory 1. She should next walk this way and add 4 to memory 4, making it 9, correct? It's still 9, so blanks don't affect it. That should be 18. She's got to go this way. And then she's got to look for an escape. And she's still looking for an escape. Okay. This step here is what's killing it. So I think if I just put this at the bottom here, and then we go, we'll see if this works. Add up the continents of each row and write the results in the cubes on the right side. And this is the first time that the arrows on the floor seem like they are useful. I'm confused as to what went wrong there. 0 plus 0 is 0. Eight is right. Should turn into 15. Next we should get three and go to 18. Wait a minute. Why did we not get that extra amount? Because this code should be done first. Let's try that. Okay, so this is 18, 7, 14, 18. And then when it comes back up at this point, I guess maybe we just put another jump here. There we go. 13 or fewer commands. We did it in 18. 32 seconds or fewer. So, is there a way to do this so it wouldn't be so many commands? Well, let's start off by saying, do we really need that set? Or does it just solve immediately with that? So, yeah. Then that just is 14 fewer commands. Let's see. Mem1, set what you're standing on, and then calculate it. You could probably save yourself some frustration and just set it to the thing in front of you. Instead of the thing you're standing on. And look ahead. Not that that really matters much. If you see a hole, if in front of you is a hole, step down. Then if it's not a thing, go that way. If it is a thing, go that way. Repeat at this point. if you were to pick up every item, add it together and write it down, you might save yourself some commands that way. So instead of doing this, you could just get rid of this, and then it's just would be changing everything, but then it never stops if I do it that way. Now, how many times can you undo things? Okay. Let's see. How can we do this better? Set mem1 to that. So then if mem1 is not equal to a number, which I guess would mean if it is equal to, if mem1 is equal to nothing, then test, I guess, if it's or and mem1 is equal to a wall. Let's see. Step down. Step. Step there. So there's an exit command inside an if command. Step down if it's a whole. If this is not equal to a whole, step up. Otherwise, step to the right and keep going. Yeah. I don't see how we get this down so much. I mean, you can definitely get rid of this. And that seems like that doesn't change anything. But you still are 4 codes short. And you still are quite a way away from trying to speed up this process. And I do think this is a consistent problem with this game, is that you are constantly trying to see different things happen. So See if in front of you is a hole. Otherwise, you could very easily set up a solution that works, but it not be the solution that that they're looking for. And then you run into this scenario where it's unlikely that you'll ever be able to iterate into the challenge solutions that they would expect from you. Let's see. Let's see. What is the part that's the problem here? If the thing in front of you is a hole, step down, then step to the right. Elsewise, step to the right until you're back to where you are. Else, if it's not a hole, set the thing in front of you, add that up, and then after you set the thing in front of you, step. Maybe the step needs to be way at the top here. If this is not a hole, is a hole. I don't think that line of code's needed. Yeah, I think the problem is the looking forward. And I don't think that really fixes much if you did look forward. Let's see. If the hole in front of you, that should be right. If the thing in front of you is a hole. But there's something wrong with the math. Still, like, this guy seems to consistently get 0 when he should be getting 5 added, and then he should be adding 5 plus 0 to get to 5, and then he should get to this point, see there's a hole, and he should step down, and he does, and then he should see that there isn't a hole, so he should step back up. And I guess that means I probably should move this out of the code. Like that. See how that works. I got 11 this time. 4 plus that is 9. That's 11. So who got the wrong number? 22 down here. 4 plus 7 plus 8 is 15. Plus another 7 would be 22. Plus 0 should be that. So who is the person that did it wrong? This is a problem because you can't pause, and I can't click on any of them. So I just have to watch somebody else and Let's watch them. 6 plus 4 should be 10. Plus 9 should be 19. Plus 6 should be 25. And yet we're not at 25, we're at 16. Let's see if this is a hole. Else if this is a wall. 4 plus 3 should be 7, plus 4 should be 11, plus 9 should be 20. So when it goes up here, it then jumps down to this point and then steps. So this is the part of the code that's the problem. How can we fix that so it's not part of the problem? Whenever these are done, this like here should jump back to that. See, 40 seconds on average. We're trying to go for 32 seconds. So how do we make this even faster? Calculate where you're standing plus that. Probably is easier. And that gets rid of memory 1. Let's see how much that speeds it up. $40 seconds still. If this equals a hole, then step down. If it doesn't equal a hole, then step, then check to see if it's a wall. If we at a certain point just didn't care and always picked things up, always wrote the biggest number down, and then always dropped it, then you can get rid of that. That shouldn't be faster though, that should be slower. And see, the number is just getting bigger and bigger and bigger to the point we can't even read it. Let's see. If this equals a hole or a wall. Still 40 seconds. See how some things don't really change it? Let's see. Do we really need this command here? See, if this is a hole, go to the right, go back. Go to the right. Go back that way. Elsewise. Get rid of this jump exit. See if that still works. Nope. This is like a mainstream puzzle, but we could just give up and move forward. Let's see, step to the right. Calculate what's you're standing on plus the thing to the right of you. That might help, actually. If you calculated the thing in front of you and then did that. So like M4 equals the thing in front of you and the thing you're standing on. And then you could step forward one more direction, but then you would have to step forward in an else statement over here. That might add some efficiency. But we lost some people in the pathfinding here. But you know, it might just be easiest to have this go back to the way it was. Let's see. Will that work? Nope, still losing people. If the thing to the right of you is a hole, go down one. If the thing up to you is not a hole, step up. Elsewise, step to the right and jump back. Why did we still lose a person? And then see, when you're stepping through this is just like slow. See, right there, this guy. He looked to the right and he saw there was a hole. and yet it didn't seem to matter. Let's see. Step to the right. Do we possibly never need to step to the right like that? Is this gonna work all the way? Still didn't quite work. Yep. And yeah, we're giving it the college try, but that's about it. Let's move on. Printing etiquette 1. Yes, we need to have a conversation. Someone in this room we won't say who, has been abusing their printing privileges. They are printing personal holiday cards, photos of themselves standing in front of the bathroom mirror, excerpts from some sort of fanfiction novella. They are clearly lonely. Yes, we need to learn to limit our printer usage, and not print like we're trapped in some sort of infinite loop, as if data can be copied indefinitely. Yes, please work through our printing mindfulness assignment. I'll just leave the pamphlet instructions over there. We need to increase awareness of our printing. Each worker must print exactly 5 data cubes and place them anywhere on the floor, and really think about the impact of each other. Okay. See, this sounds just almost undoable. Like, we can find the printer, certainly, and that's fine, but then that puts everybody's question next would be to say is drop it what you've just picked up. So pick up from the printer, drop it. If you're still holding an item, as in your item is not equal to nothing, then step up 1 and keep doing that. This will make a line this way, and then what we're going to do is set this location in memory 2, and what we're going to do is have you then go back and pick up something from memory 1 a second time, and then we're going to step to memory 2, and then we're going to step 1 to the right of memory 2, and then we're going to drop. And if we wanted to do this exactly 5 times, how do we stop that? What we do is we calculate a memory 3 into equaling memory 3 plus 1, and we're going to make a function loop. Basically, if memory 3 is not equal to 6, which would be 1, then, which it's probably better to just write it as is less than 5. Although, if you get down to the cores of CPUing, processing, testing to see if something is less than 5, probably does take a little bit more time than testing if something is exactly a number, because exactly a number has a lot more scenarios that are partial, are not partial matches. So if it's less than 5, then do this again, and we'll go ahead and set memory 3 to 0, so we know. And then jump back. Oops. Let's see. Step. It's not pick up, it's take from memory 1. Some of these arguments a little too close to each other. Again, take from memory 1. And they seem to go up and up and up. So what are we missing now? We get this one, and so now it's in this, it should be in a loop. It should be take from this, go to where it is, okay, step to where it is, drop, add, still waiting to go. In a funny way, these codes run with interrupts, which programming and understanding interrupts are not particularly fun. Okay, I think I get the idea what I missed here. Set mem2 to where we're standing every time, and that should get this bottom one to work. So we should get at least a straight line of this. And then we just need to adjust these other people. Come on, let's speed this up. This doesn't make sense. Alright, and then the next thing is take it, drop it if you're still holding a thing, step up, and then drop. That might be that simple. Why are they all going to the right? See, that doesn't fully make sense. So this guy's gonna be the second one. He's gonna pick one up. He can't drop it, so he's gonna go up. He can drop it now. So now he sets his memory to as that position. He now takes from it, and he should be stepping to his memory too. And then he should be walking this way. And he should be setting his new memory too. Why didn't he? Why is his mem 2 nothing when his mem 2 should be something? Okay, well, see if he instead sets the mem 2, step to mem 2, drop where it is, set mem 2 to the right of you. You could eliminate that step, I think. Let's see. That didn't quite work. Mem 2. You probably don't need that code. Take from the first one. And then drop it. And then if that doesn't work, set your mem 2 in this direction to the right. Let's see. What is going wrong? You have this that has 45. He drops it, and then it wants to step to mem 2, which should probably be that point. Something is already there. I'm already holding something. Something is already here. Let's see. It almost feels like what I should do is I should pick it up, go up here, and start at the top. And honestly, that shouldn't change the code really any. But let's give it a try. So we take one from here. If, and let's see, if our item equals nothing, it's not equal to nothing, step up. Jump that way and keep on trying. But that code doesn't seem to work. Or to say, more accurately to say, none of those people seem to get to that point. Like, everybody is stuck except for this one character who was working a second ago. Let's see, take from M1. Set where you're standing as Mem2. Step to Mem2. Step to the right. Then drop. See how that fixes things. And there's really like no talking or telling really as far as just who's gonna go in what order and what this is all, how this is all gonna work out. So what happens after the first cycle? You get another one. You step to where you are. You set Mem2 to where you are, which is kind of doing nothing. Then you should really be doing that. But is the memory shared or not? Because sometimes it seems like it is, sometimes it seems like it isn't. Do we even have a solution here? No. So, you know, if we watch this guy, he should pick up something, go up north. Should go up one. Okay, he should drop one now. And that should be his Mem2. It's that 48. He should now step back to his Mem2, which he does. And then he should step to the right. And then he should set that as his new M2, which is nothing. So it has to be drop it, then set it, then calculate. See if that fixes the problem. Let's now take this down 2 and see if that fixes that. There's our solution. We did in 15 lines of code, and by the looks of it, we'd only need to save 3 seconds. So, what could we do to remove one thing? This mem2 set, does it need to be? Well, can we actually add a direction to something? Would that work? Yeah, but it probably isn't changing anything unless I get rid of the other code. See if it works now. I think the answer to that is no. Let's see, what would make this faster? If this was less than or equal to 4, probably wouldn't be any faster. We could probably have everything take from 1, but I don't know if that's any faster. What is getting done faster? Probably let's see. If we do this, if what's in your hand is not equal to nothing, so step up and then drop, and then see if that changes anything, because you can't really drop something twice anyways. "61 seconds. Interesting. So that took 10 seconds more to do it that way. Let's see. Take from something, drop. It might be easier to say if what I'm standing in is not equal to, nothing, elsewise drop. That's 58 seconds again. If the thing you're standing on, let's see, mem2 equals set, which really should just be go to where there's a empty spot, step to that empty spot, and then you can get rid of that, and then drop, and then set to your next empty spot over that way. That's really how that should work. But it won't work because you don't get locations, you only get, yeah, you just can't do it that way because there's no reference. So step in that direction. And then the drop here should work every single time. Is it possibly more efficient just to go into a cycle and walk to the right instead? To say basically, if what you're standing on is not equal to nothing, step to the right and keep doing that until it isn't, else drop. Thus we don't have to reestablish M2 after that point. See how that works. If anything, that should be slower. Yeah, that is slower. I would think that would be slower. That would make all the sense in the world that that would be slower. Man, and they keep moving the location of things, so the location of the button, that's just bad UI design. We don't need that else command. We could put this take from command maybe somewhere else. Take from, step to memory 2. Let's see. Let's give it a little bit of a college try as far as shorter lines of code. Less code. What is a dumber way to do this, but it would be still possible of doing it that way? Let's see. You know what a printer is? You can take from the printer, you could drop, and if you drop, you go in a loop that sets your location of where that is. Then you could go back and then if we put step 2 here and then had this, and then step here and then set that. Alright, that probably eliminates that much. If this is less than 5, do this every time. Take it, step to it, step to the right, drop it. If after dropping it you haven't dropped it, then go up 1 and drop it again, and then set that to that point. And let's see how this plays. That's 12 lines of code, so how do you take out even more lines of code? Mem 1 is the printer. I don't think we're getting rid of that. This if statement needs to be here. We can take from it, and then we can go to where we need to go. Or, you know what we do? We get rid of the mem stuff, since it doesn't matter. All they needed to do is pick up 5 pieces of paper and put them on anywhere on the floor. So I overcomplicated things by putting everything nice and neat, when really all I could do is say step in any random direction, drop if you're still holding an item in any random direction, go anywhere, any direction at all. Yeah, I think that's pretty much it. That's 9 lines of code. So just go in random directions and drop the boxes. Each one individually will drop 5 boxes, but not in any order that you could really follow or confirm. And because it's random, there is a pretty inconsistent consistency there. Let's move back up to... Actually, let's go back in here and just copy our original form answer, because I imagine printing etiquette 2 is going to use it. Hopefully. Year 40. Working at the same place for 40 years. Notice everybody seems a little bit older. Here we are again. Yes, it appears our polite printing pamphlet was out of date in the previous assignment and we wanted 25 data cubes. Please enjoy your updated assignment. Well, let's go ahead and paste that. But the easiest thing to do would be to simply copy this one and it's nice that all of these auto save. Right. So paste this. All we have to do now is change the number to 25. That's it. And go. Is 25 going to fill the whole room up, I wonder? You can definitely tell there's some extra coding that the programmers had to do to make sure this would all work. In a funny way, this is just basically similar to a previous puzzle we did where it was just put a bunch of things. Yeah, it seems like either I'm one off and it should be less than 26, which is unbelievable, or we are, yeah. Let's see. Wait a minute, what does this say? Go copy the solution from your previous assignment. Once you each worker must print exactly 5 data cubes, but this time each worker must label their cubes 1 through 5 in any order. Label their cubes 1 through 5 in any order. I don't understand. But this time each worker must label their cubes 1 through 5 in any order you like. Place them on the floor. Anywhere on the floor. Well, would this solution work? Let's see. It does kind of seem like what you're supposed to do is just write mem3 here. Let's see if that's all it takes. Let's see. Right. Mem3. Let's go back this way and get that third copy of the code. It's weird they only really give you 3 copies. Feels like they could easily give you 6 copies or major backups. And I feel like a lot of these games should probably try to introduce some versioning software like GitHub or something like that to make sure that everything is on the up and up, and you can comment on how everything is going and how things change. That's certainly on bigger softwares where things are going to get crazy. Let's see. See if this works. 0, write it down. Pick the next one. 1. That seems like that might work. The only thing is we need to add a couple numbers. Actually, probably overshot it there because it's starting with 0. It should stop at 5. Yep. Which also means that we need mem3 to start at 1. So we can do that fairly easily. Set to number 1. 1 through 5, like a human would do, instead of a computer starting at 0. Well. Fourth time's a charm. So, how do I get it down to 55 seconds to speed this whole thing up? Or how would I change it in any other way to remove the amount of code, the redundant code stuff? Let's see. Well, I can't immediately see a way to get rid of the code and make it faster. Let's see, we can. Right. We can set mem3 to equal itself plus 1 first. That solves one problem. Then we just move that to 6. And then we take from 1. We try and drop. If we can drop, we do. Otherwise, we go around. See if that works. And so that's how you do it in 10 or fewer lines of code. So yeah, these are just the solutions to the previous ones. And I do like that these are iterative. I kind of wish there was kind of more of a foundational through line though. As far as this one, I don't see how you make this faster. It finds its place, it writes it or drops it, then it sets its memory, and then it indicates. Let's see. We could always have the memory here go up 1, and we could eliminate having to set it to 1 in the first place. And then we can do that. Let's see, mem3. See, what did I just do? 1 is the printer. Mem3 should be this. Got it backwards, I think. I don't know how you would remove the time or speed this up any further. Let's see. It starts at 1. Why did that not work? Okay. Moving the same variable back and forth, which definitely shows that I'm getting a little exhausted mentally with this. So, how do you get another 9 seconds off of this? By, let's see, taking from something and then stepping I could do it twice, but I don't know why that would be any faster. I mean, because that really would be the case, is you could just unroll this loop and you could say take from mem1 step to mem2 step in this direction twice, and let's see. Yeah, it just seems like an incredibly inefficient way to do it, though. For something where you're trying to create efficiency, that doesn't pass the smell test. Yeah. Oddly, I think it is probably just the solution here is to unroll this. Just instead of it having this section, which if I could just copy and paste this stuff for real, like highlight the text and copy and paste it instead of having to, like, here, let's see if we could do this. I'll just pull up Notepad and paste it into Notepad, and we'll see the part here that we can take. And looking at Notepad, that brings about an interesting thing, because this command does not really work. Like, these commands don't look anything like what we're typing here. So that becomes a big issue if you were even going to try and have some assistance by doing this over and over again. It really just would confuse the issue, because now you've got to learn 2 languages. Paste that 4 times or 5 times. 3, 4, 5. Select all, copy, and paste. Can't paste that here. It doesn't appear to be a valid program. I barely even changed it. And yet something there is missing. Like, I did not even type a single thing. So why it can't even recognize its own code? I mean, it's just ridiculous. So yeah, it's kind of pointless to have the copy and paste feature when literally the only people that could ever use the copy and paste feature would be the experts putting the answers online, and probably the creators of the game themselves. Whereas everyone else, even if you were going to try to get a little bit of help by using Notepad and do some copying and pasting, since there is no actual copying and pasting here, it's ridiculous. Like, I really think the answer to this would probably be to just unroll the code. And unrolling is a term when you unroll loops, which a compiler does that anyway. So the idea that that's what they really want you to do is not a satisfactory answer, for sure. So, let's see, right. Let's see. Right, mem3. And then let's see. Mem3 equals mem3 plus 1, and then drop. So if I did that right, there should be something. This should work. But obviously I missed something. Let's see. Kind of just fails there. Yeah. It's not really satisfactory. Moving on to image decryptor. And maybe I'll do some of that stuff off screen and find the solutions online, or just spend hours upon hours wasting my time doing it. Like, there certainly is a lot of room here to grind in a weird way, but I don't know if that's worth anyone's effort. Happy birthday to me. How nice. I was sent a birthday image from my bank, but it's a secure image and they encrypted it. Now I have to figure out how to view it. Yes, I'll just log in here to my secure online banking portal and verify my security questions and type in the security code they sent to my mobile device and type in my previous 4 addresses and accept the updated terms and conditions and agree to paperless communication and navigate the tutorial on how they recently slightly redesigned one of the buttons on the website and decline a credit card offer and decline another one. Okay, here I go. Here's how to view your birthday image. An image of a lady here with a big hairdo says, "It's so easy." They say we have to move each cube to the left number of tiles listed on each cube. Once that's completed, my personal birthday greeting will appear. Oh boy, I can't wait. Okay, each one of these guys is standing next to a cube. That's easy enough. So pick it up and then set the value of your item to memory 1, and then if memory 1 is not equal to 0, step to the left, else drop, jump back this way, and then go ahead and calculate memory 1 to be memory 1 minus 1. See if that works. We might be off by 1. So little man. So little stickman, we got it right. We were just off by 1. Okay. So -1 is not equal to, it's not less than 0. Is greater than 0. Step to the left. Do it. If it's not greater than 0, greater than or equal to 0. Let's try it that time. Let's see. Move each data cube. It says move each data cube to the left the number of times tile floors listed on each cube. For example, if it says a 3, it must move to the left 3 tiles. Since this important birthday message is private, all workers must then exit the room by stepping into one of the conveniently placed infinite loops. Okay. I see. That's the next thing to do. Nearest hole can be memory 1 again at that point, and they can just jump right to it. Well, isn't that nice? It looks just like me. Happy birthday to me. Okay. So then how would we reduce this code by 2 lines of code? Let's see. Mem1 is your item, which is there possibly a reason to do that? Or could we just say if your item is greater than or equal to 0 instead of doing that, just write. No, because then you'd have to calculate things and that would just take up more lines of code. Let's see. How can we do this? Probably get rid of that part and that part and that part. Or is there a way that 2 commands would be better than, like, I could go in an infinite loop and just have them walk all upwards. But I don't know if that would help anything. So now we've got it down to 19. So let's see, mem1. Could we, the pickup is a one-time thing, the drop is a one-time thing. If this, is there a way to loop this? Or is there a smarter way to calculate this? Mem1 equals that in a specific direction. So that we could step in a specific direction a certain number of times based on the item. That would be nice. Instead of having to loop it all over yourself, it would be nice if you could just say, I know the value of this, I want this to be a location that is the value of this, plus that 7 times to the left. If my item is greater than or equal to 0, step to the right, then write to my item the value of that. Or calculate. Yeah, all calculations end up in memory. So doing anything like that would be kind of silly. Step in a direction for less. And see, I don't know how you would do this without incrementing. I could say, you could probably say set another number like mem2 to 0, and then if you say if mem2 is not equal to mem1, step to the right, but then you still would have to calculate m2 to be +1 of itself and increment it. So that doesn't really save you any line of code in any way. Let's see. Pick up, drop. Pick up, drop. Let's see. Would that help you any to move the drop? I mean, you're still going to have one drop command. And then step to the nearest hole. That's not where the command needs to be optimized either. This is 1, 2, 3, 4 lines of code at most. Is there a way in 3 lines of code I could figure out? Let's see, if I set this here to my location, so we'll go ahead and say mem2 is our location where we just picked up things, and then we should set mem2 to be mem2 minus the value of our item. That seems like that wouldn't really work. And then step straight to mem2. Get rid of that. Get rid of that. Get rid of that. Let's see if this works. Yeah, that didn't. Let's see what happens. So it picks up the item, finds out that mem1 is 5, and then mem2 should be the location. Let's see. So step to the right here, pick up here after a second. M2 is that. Then pick up. See if that works. Step to the right. They now know the location. They should now know a value. They should now say take the value of mem2, which is a location, and subtract 5, which you would think means go left, and put that in mem2, and that gave them a 0. Yeah. There's no conversion like that in this game. You could do that certainly with other things, but not this way. So setting up a lot of that is not useful. Get an item. Subtract some amount of number. Zero minus the value of the item. That gives you a negative number. And then what are we trying to do? Step left. If and jump. If your mem1 is less than your item. I don't think that's gonna work. So 0 minus our item should give us a negative number, and it didn't. Like usually in a coding aspect, you would be able just to increment and decrement things a lot easier than the way this is going. Let's see. See, I don't know why this would be any better than what we had before. Just say your item is your item plus nothing, and then as long as it's equal, greater than or equal to 0, just subtract 1. That was 9, and they want us to do it in 8. So what's the one command that's unnecessary here? The pickup command? The initial setup command here? Let's see. If you pick up the item, then maybe you don't need to set it. Mm-hmm. The only thing that even seems like it would be unnecessary is this initial setting up of memory 1. Which, I mean, I guess you could do this and then do this and do this. But there is a difference in that. Definitely. Get rid of that. Then write that. Still at 9, want to be at 8. If the direction is this way, that wouldn't work. So you pick it up, the item you have becomes mem1. So you could potentially have mem1 be your item minus -1. Okay. Plus mem1 could be mem1 -1 as long as your item that you're holding is not equal to mem1. And then we change this to a plus. Maybe that would work. Almost that. It's not equal to it as long as your item is greater than it. Not greater than, less than it? No, that's definitely not it. Greater than or equal to it. Still one off. Greater than or equal to it. Mem1 equals mem1 after that point. Think I've got it. So we got it in 8 commands. Doing some weirdness, definitely. Like, even if I just blink right now, I think I probably would have a hard time wrapping my head around this as I'm getting a little groggy around this all. But yeah. And then how would we want this code to potentially be more efficient? That would be the question. How can we play this so it goes quicker? Greater than or equal to. Let's just double check to make sure we had already done this. What was our fastest target speed? 33 seconds. We want to get it down to 15 seconds. Wow, that is a lot. That is definitely a lot. Let's see. Well, you don't need this part or this part or this part. Let's see. We could unroll everything. But you can't even calculate for even or odds, so that would be kind of hard to do. Is there some better system here to speed this up? Find the fastest hole, go to it, and jump in. Let's see. M1 is your item plus 1 minus 1. Go ahead and write that to your item. How can we do this more efficiently? The thing you want to do is have it decide that your item is less, as long as your item is less than 0, it should just go to that, and then it should write mem1 and mem1 should be that minus that, and then it should calculate mem1 originally to the value of the item plus 1. So let's see if that works. As long as your item is greater than 0, But this is yet again another one of these puzzles that it doesn't make any sense at all as to why this would be 10 seconds, 15 seconds. There's parts of this drawing when it draws the little stick figure that wouldn't have a data cube next to it. So I could possibly wait for a worker, but I couldn't really wait for a worker, could I? So yeah, I really have no clue as to how you would do that in 15 seconds by their own integration. Well, we made it up to 42 and 43, and then one more purple-blue button, and then we're into the orange, and then we're into the red. And so I could see 3 or 4 more episodes will be completely done. I think there's a decent chance that I'll spend some extra time playing around. A lot of these things still don't really make sense. Like, I'm still not really sure how you would program this to be more efficient. Let's see. This is the one that worked. And that can get us to the start. Our best has been 10 commands, and our best has been 3 seconds. So, yeah. I don't know, with this limited number of commands, many of which don't have the full setup, I don't know how you would get this to decide to pick something up I guess this is trying to pick something up, and then you could say if you're standing on something, I guess, then pick it up. And so if this is a data cube, pick it up and then step to the right forever. Else if to the right of you is a data cube, pick it up and then step to the right forever. Get rid of that jump, get rid of that jump. Get rid of this if command. That's still 9 commands, and that's still... It didn't seem like that worked even. And you can't choose multiple things at the moment. So let's see. Do we need to actually pick up? Oh, you don't need to pick up things. Well, that can get you down to 7 lines of code. And then that means I guess I could get down to 6 lines of code. So, yeah, I'm just overthinking it. And that might very well be the problem with a lot of these puzzles, is that I'm overthinking things. Let's see. If I was to make this an else statement instead, so else just step this way and get rid of that. That's fine, but it doesn't really change anything. It would be so nice if you could just step in the direction that you were going to step anyway. So we've got to get a way to continuously jump with only 5 commands. Let's see. It would be kind of crazy to pick up, then step to the right, and then drop. So, like, pick up a thing, step to the right, and then drop. Get rid of that jump. Get rid of that jump. It's still 6 commands. That just makes it more complicated. 5 or fewer commands. And we're at 6. Oh, well, what if we got rid of the else command? Then we're at 5. If it's one way, this will get you into an infinite loop. Otherwise, just assume it's the other way and get to that way. Alright, well, that got both things done. Nice. So yeah, I feel like I might do a lot of this off screen, but anyways, we've gone 2 hours. That's going to be it for this recording. As always, I ask you to like, share, subscribe, comment, and watch every second of my videos. If you want a friend or follow me on any social media sites, there's a whole bunch of links down below in the description box. And if you want to support me further, there's a link to Patreon, or you can friend me on Steam and gift me a game off my wishlist. Thank you for watching. Have a good evening.